Problem 7 in our review packet tells us to solve triangle ABC using the given diagram, which you have here, and our given measurements. So I'm going to begin by putting in the given information into my diagram, which is 30 degrees, and side B is 7. So I can easily find angle A, alright, because we know angle A and angle B are complementary when we have a 90-degree angle of C. So I'm going to subtract 30 from 90, and we can see angle A is 60 degrees. So I hope you're noticing that you have a special triangle here. You have a 30, 60, 90 triangle. So when you have a special triangle as this, you're going to need to give exact values. There will not be rounding. That's not acceptable. So there's two ways to do this. I will show you both ways. The first way is the knowledge of the 30, 60, 90 triangle. Alright, so I'm going to draw a second triangle up here. Alright, and it's definitely not to scale. Alright, so we've got our 30-degree angle here, our 60-degree angle here. Alright, the side opposite your 30-degree angle will be 1. Alright, the side opposite the 60-degree angle, we're going to put square root of 3. And the side opposite, or the hypotenuse will be 2. So what this shows us is, if we know the side opposite the 30-degree angle, alright, we can easily find the side opposite the 60-degree angle by multiplying this side by the square root of 3. What's 1 times the square root of 3? Square root of 3. So I can do that for A. Say, oh, I've got the side opposite the 30-degree angle. So to find side A, which is opposite the 60-degree angle, I just simply multiply 7 by square root of 3. And my answer will be 7 square root of 3. We can see the hypotenuse is double the length of the shortest side, which is opposite 30 degrees. So 1 times 2 is 2. So to get my hypotenuse here, I just have to double my shortest side, which is B. So 7 times 2 will give me 14. And I've solved my triangle. Perfectly acceptable. Alright, you can also use trig. Alright, if you don't remember this, alright, and you want to just result to trig, go ahead and do that. Alright, but you're going to have to know the ratios and what let's say sine of 30 degrees equals. Alright, and we'll take a look at that. And I've got a table here which I'll pop up in a second. Alright, so let's use trig. Alright, I've got my given information, which is 30 degrees. Alright, and the given information here, B is 7. So let's say we want to find A. Alright, pretend we don't know it's 7 root 3. Alright, where is A in relation or in orientation to 30 degrees? It's adjacent. The given information is opposite, so what trig function is that? Opposite over adjacent, that's the tan function. So I'm going to say tan of 30 degrees is opposite, which is 7, over my unknown side, which is A. So I know tan of 30 degrees, there's a table that you guys are familiar with, so I'm going to pop over to this table here. And I'm going to look at tangent and 30 degrees and see where they meet. And they meet at square root of 3 over 3. So tangent of 30 degrees has an exact value of square root of 3 over 3. So instead of tan of 30, I'm going to plug in square root of 3 over 3. That's going to equal 7 over A. Now I have two ratios that are equal to each other, so I can use cross multiplication. So I'm going to multiply A by the square root of 3, and 3 times 7, which gives me 21. And I'm going to want to solve for A, so I'm going to divide by the square root of 3. This will cancel, and I'll see A equals what? I've got 21 over the square root of 3. We know we can't leave it like that because there's a square root in the denominator, so it's not simplified. So I need to rationalize the denominator by multiplying by square root of 3 over square root of 3. And I'm going to have 21 root 3 over 3. And I hope you're all realizing that 21 and 3 can simplify. What's 21 divided by 3? That's 7 times the square root of 3 is 7 root 3. And that's what we had here originally. Okay, so either way you can use to find side A. Now let's find our unknown C. Alright, so I'm going to go back to my given information, 30 degrees. The opposite side was 7. C is the hypotenuse, so I have opposite over hypotenuse. Well, that's sine. So I have sine of 30 degrees is equal to the opposite, which is 7, over the hypotenuse, which is C. Well, what is the exact value of sine of 30 degrees? So I'm going to go to my table, look for sine 30 degrees, and I can see the exact value of sine of 30 degrees is 1/2. So I'm going to substitute 1/2 for sine of 30 degrees. I have two ratios that are equal to each other, so I can use cross multiplication. 1 times C is simply C. 2 times 7, well, that's 14. That's what we had here. Either way, our triangle is solved.